Morning.
How are you today?
I'm doing pretty good. How about you?
Good. Weather's still holding out. Kind of a little cold last night, but
Yeah, I got a little windy.
cold by California standards, which is we're still in our short sleeve shirts. Actually, we might throw on a sweater. And let's see. So, Chris, good morning. Colton, good morning. That's all we got so far. Just two. One here and one there. And I'm pointing my different screens. Well, how was your programming over the weekend? Any questions, comments about it? Got those arrays?
Not for me. It was fairly straightforward.
Got those arrays filled up?
Yeah.
All right. I haven't had a chance to look at those yet. Hopefully by Thursday, I'll have a chance to look at those, and then we'll take a look at how people did on those. There's many different ways to do that. Well, hello to India from California. It's probably in the middle of the night. Oh, I see. You had a different name yesterday. Got it. All right. Well, since there aren't any comments about the assignment over the weekend, why don't we get started with today's stuff? So today we're kind of picking up where we left off last time. Remember last time we wrote this program. Let me scroll up through it. It was the one that defined an array with 5 elements in it and then printed it out. We also had a function for inputting the array from the user. Another one for just taking all the numbers in the array and doubling them. And one function for finding the maximum out of all those numbers. And then a main. And the original main that we had called each of those functions in succession. In preparation for today, I went and modified main a little bit. So rather than calling input array to get numbers from the user, I've just got it set up now to simply put those numbers directly into the array. And then it calls print array right off the bat. And also I've adjusted the size. If I scroll back up to the top briefly, you can see I've changed the size to 10 to make this array a little bit bigger. Let's just make sure it works with what I got so far. It's going to print out the array and then tell me what the largest number is. Seems to be working. The largest number is 12. That's this one here. So as far as new functions go, I want to write some really basic functions that manipulate an array, but are a little more complex than just simply finding the largest or inputting them or printing them. The first one I want to do, actually it's not that much more complicated, is to find the sum, to add up all the numbers in the array. So I want to be able to do something like int sum equals sum array, pass in the array name and its size, and then print out the sum. So it's not going to be that much different from finding the largest. What's the general idea behind summing up an array? If you could just kind of describe it in words.
You'll want to have one variable to keep track of the sum, and then loop through the array and add each element to the sum.
Good. So you want a variable to accumulate the sum as you go, and then you run through the array, adding each element of the array to that accumulated sum, and then when you're done, you can just return that. So let's call this ACC for accumulator. We could call it sum also as well, but I'll go with ACC, and then we're just going to write our standard loop that goes from the beginning to the end. Inside the loop, we just simply add each element of the array to that accumulator. And then when we're all done, just return the sum, or the accumulated value. Okay, so let's take a look at this, and let's go ahead and calculate this kind of by hand, and just make sure that when we come up with the sum, we've got this actual answer. So 4 plus 1 is 5, plus 9 is 14. Take away 3, you get 11. Add 12, that's 23, 26, 35, take away 5, that should leave 30, and then add 10, we should get 40. So if I've done this calculation correctly, we should end up with 40. Oh, what did I do wrong here? Ah, I see it, but do you see it?
Yeah, the first parameter on in the method header for sum array should have the square brackets.
So the error message here says incompatible pointer to integer conversion, passing int array with 10 elements to parameter type int. So here's an example where the types did not match up. The compiler expected the function to be passed just a single integer, but we tried to pass it an integer array. So types didn't match, although all it did was it let it go with a warning. So let that go with a warning. This however produced an error. It said, hey, ARR is declared to be an integer, and you tried to access it as an array, and that's an error. So let's go and put these brackets in, save it, compile it, and then we got no errors. Good. Uh-oh. We ended up with 52. And let me just quickly add these up here. We got 4 plus 1 plus 9 plus negative 3 plus 12 plus 3 plus 9 minus 5 plus 10. And I do end up with 40. But how did I end up with 52?
I'm guessing it's because we're not initializing the accumulator variable.
That's most likely it right there. This accumulator ended up with some garbage value, 12 I'm guessing, and then it just went from there. So it's important when you are creating your variables, if you are not immediately assigning to them, that you go ahead and initialize them. That's better. Now we get 40. Okay, so that was it. Not initializing the variable. And then I guess I should ask, has that caught anyone yet? Have you written your programs and didn't get an expected value? Now sometimes you get a really outlandish value, like a huge negative number or a huge positive number, and you go, that's definitely not right. And you should immediately think, oh, that looks like a garbage value. I probably didn't initialize it. But in this case, we were just close enough that if I hadn't gone and added up those numbers by hand, we might have just accepted it. And said, oh, that looks like 52. So testing is really important, right? And not just accepting what the computer says as being the correct answer. Okay, so that's sum. Now, right here on this statement here, there's a couple different ways we could write this. We could have shortened it slightly to accumulator plus equals the ith element of the array. There's no real difference between those two. One's not faster than the other. There was a time many years ago, 30, 40 years ago, when doing it the way I originally had it on the screen would have been slightly slower than doing it this way, but that's not the case anymore. Today's modern processors and modern optimizing compilers will just compile those into the same code. So do whichever one you think makes the most sense to you. Okay, so the next one I want to do is to calculate the average. Let's find the average of all of these numbers. And since the sum came out to be 40, the average should be 4. However, that is just luck that we ended up with an integer average. Probably in general, we'd end up with a decimal number average. So let's go ahead and have average return a float. Now I think maybe just to make the point clear, I'm going to go ahead and change one of these numbers so that we don't end up with a nice round 40 at the end. Let's go ahead and make, let's make this one here be 5. So we end up with 42 as the sum. Great. So how do we calculate the average? Anyone?
Well, you want to take the sum divided by the length, and you'll want to make sure that at least one of those is cast or treated as a float so that you don't do integer division.
Okay. So I should start with a loop to sum it up.
Well, we can call the method SumArray.
Oh, good. We've already got a method to sum up the array. So why reinvent the wheel? Why don't we just use one that we know works, right? We tested it out. We actually found a bug in it, and we fixed that bug. So we're pretty sure that one works. Let's go ahead and just call that. So we can just really just return some array, and we'll pass in the array and a length. And then we'll just divide it by the length. So I'll go ahead and save that, and then down here, let's put in float av equals average nums and size. And Chris, I know you made one more comment about it, but I'm just going to, for illustration purposes, not do that just yet. Okay, so it came up with an average of 4.0, but it should have been 4.2. So we have a bug in average. And so Chris, what was it again?
Right now we're dividing an integer by an integer. So we're doing integer division where the remainder is dropped.
Yep. So SumArray returns an integer, which we can tell because that's how it was declared. And length is an integer. So it'll do integer divided by integer, come up with an integer answer, and drop off any fractional value. So to solve that, we need to cast at least one of these to be a float, and that'll force the entire calculation to be done as floats. So we can either cast the return value from SumArray to be a float, or we could cast the value of length to be a float. Either one will work. What will not work, however, is to cast the entire calculation to be a float, because in this case, it'll do the inside the parentheses first. So it'll do integer divided by integer, come up with 4, and then cast that as a float. So just make sure when you do these casts that you're applying it to just one of the operands, not to the result of the expression. So let's give that a shot. And now we get 4.2, which is what we wanted. Okay, now some more interesting things. Now I want to do a function called rotate. Let's take a look at this. Rotate. Let's say my array is 5, 2, 1, 3, 9. What rotate is going to do is it's going to move each element down one spot, and then the last one is going to go to the end of the line. So everyone's going to move down one slot, and the one that was first in line is going to go to the end. So we're basically doing a rotation. So let's call this ARR. This is element number 0, 1, 2, 3, and 4. So some of you may look at this and go, I know exactly what I have to write in order to make this happen. And some of you may try something and it doesn't quite work. And so what I suggest, if you can't get it to work right away, is take a step backwards and let's actually analyze what's supposed to happen. Now, I'll have to tell you, if I'm writing a program that involves a complex loop, or a loop involving lots of kind of moving pieces, it's easier for me to analyze the program if I just write down the steps it takes to do what I want to do without using a loop at all. What statements would I have to write in order to move these 5 elements into the right spots? So we're going to use this array with these numbers and this length. It's got 5 elements in there, and it's the numbers 5, 2, 1, 3, and 9. Actually, it doesn't have to be these numbers, but it has to be this array. So 5 elements in the array. What statements would we write to move things into the right spots? So I can get you started here. Here's one of the statements. We're going to take some element of the array and have that take on the value of some other element in the array. So for example, what if we move this 2 where the 5 was? So I would put here element number 0 gets element number 1. And then element number, let's write down another one. Now, since 5 numbers are going to be moving, I'm probably going to need 5 statements to do this. Let me go ahead and just fill in these 5 statements, and then we'll put in the numbers in a moment. So I'm not going to make a new array. I can do this entirely in place. I can take my existing array and just shuffle these numbers around. What numbers do I have to put into these spots to rotate this array? So this is how it's going to start, and then I want it to become 2, 1, 3, 9, 5, where the 2 is now in element 0, the 1 is in 1, the 3 is in 2, the 9 is in 3, and the 5 is in 4. So do you already see a problem with the statement I wrote here?
Yeah, if you just if you do the assignment statements all the way down, you'll lose track of what the 0th position is,
Yeah.
value is.
Yeah. I think Colton on YouTube is kind of hinting at that with his comment. Is that by taking this 2 and putting it where the 5 was, I've now lost the 5. So maybe there's something I should do first. Maybe what I should do is I should take this 5 and just kind of store it away somewhere and free up that slot so that I can move everything else into position. So I should probably do that first. Let me put that up at the top here. Let's go int temp equals ARR 0. So store away element 0. And now I can move element number 1 into 0 spot. And that's what this statement does. And then I can move element number 2 into 1 spot. Element number 2 will get 3s. Element number 3 will get 4. And then element number 4 will get what?
Zero?
No, not 0.
Will be the variable temp.
Yeah. Okay, so remember, by the time I get to the end of this statement here, what I've got now is 2, 1, 3, 9, 9. Okay, so the 5 was here, and we replace it with the 2. The 2 was here, and replace it with the 1. The 1 was here, the 3 came down, and the 3 was here, and the 9 came down, so 9 is still repeated. So the 5 we're looking for, which needs to go in here, is sitting in this temporary variable. So this needs to be array 4 gets the value of temp. Okay, so we've only got 5 boxes with which to fill in. If you were to tell everyone in line to like move down a slot, what would happen is, I mean, literally like in a cashier's line, right? So there's 5 people in the cashier's line at the store, and everyone wants to move down a slot. Well, there's only 5 slots. The person at the front of the line has no place to go. So you've got to like move them off to the side into a new slot, a new box, and then now everyone else can move down 1 slot, and then you can take the person who was first and put them on the back of the line. Or maybe a more apt analogy is like when you're practicing basketball or something like that, right? Or tennis, right? Everyone has to like line up at the end of the court, and then the coach, fires balls at them, and you've got this line of players going through. The person at the front of the line does their thing, and then everyone shifts down, and that last player goes to the end. Well, they've got to temporarily step aside so that everyone else has place to move down. Okay, so these are the 6 statements that we need to rotate this array of 5. And now that I've got those statements down, well, what I'm going to do first actually is I'm going to go ahead and, I was going to put this in the program, but I realize now my program actually has 10 elements in it, and I really don't want to write 10 things out. So the next thing to do would be, if we're convinced that these are the 5 statements that will rotate this array of 5 down by 1 slot, can we look at this and figure out, can we turn this into a loop? So I look at this and I go, are there a bunch of statements in here that are very similar to each other but are repeating? And are there any other statements in here of which there's only one of them? So I see the first statement and the last statement there are different from the others. and these middle 4 are pretty similar to each other. So that lets me know that this one here probably goes in front of the loop, so before the loop even starts, so it only gets done once. The one at the end also only gets done once, and will be done after the loop is finished. And these 4 in the middle are what gets done inside the loop. So let's look at how to construct this loop. The next thing I would look for is to see, are there any relationships between these things that are changing? What I do see here is that the first numbers are going 0, 1, 2, 3, and the second numbers are going 1, 2, 3, 4. So maybe as a first kind of pass, I could think like, well, that means I need 2 variables. I need one that starts at 0 and counts up to 3, and I need one that starts at 1 and counts up to 4. But you could do one better and see that the first number can be calculated from the second number, or vice versa. The second number can be calculated from the first number. The numbers that are inside the brackets on each statement differ always by exactly 1. Okay, so this statement here is going to be before the loop. And then we're going to go into a loop. Let's use the first numbers as our I variable. And then these numbers over here, the 1, 2, 3, 4, could just simply be I plus 1. So whatever the value of I is, which would be the first number, the second number will always just be 1 more than that. And then this last statement comes in after the loop. Oh, whoops. This, I already see a mistake here. This should be... Oh, no, that's right. That's right. That should be 4. Okay, so one more piece here. What goes here? What is I less than? So one option here is I could put length right here. Will that work?
If you put length, it'll loop through the entire array, but we don't actually want to loop the last element.
Yeah, this is going to go 0, 1, 2, 3, but the highest index in the array is 4, and we don't actually want the 4 to be inside the loop. We only want the loop to go up to the length of the array minus 1. And the last thing to do is, can we replace this 4 with something else? Like the 4 works for an array with exactly 5 elements, but ours is going to be 10 elements.
So we could do length minus 1.
Mm-hmm. Good. Several other people also commented the same thing. So let's try this. Now, this function is going to make changes to the array in place. It's not going to create a new array, so it doesn't need to return anything. It's going to be passed in the array. It's going to make changes to the array itself, and then once it is done, the array will now be changed and nothing needs to be returned. So we're going to declare this to be void. We'll call this rotate, pass in our array and our length. And then I'm just going to write in those statements that I had on the screen a moment ago. Int temp equals array 0, for int I equals 0, I is less than length minus 1, I plus plus. Array I is equal to array I plus 1. And then outside the loop, array length minus 1 is equal to temp. Let's see, Colton's asking, is this more like shifting the array than rotating it? Shifting is similar. You're going to move everyone down one slot, but when you do a shift, the array gets shorter. The one at the front of the line just goes away. This is a rotate because we're making a circle. The one at the front of the line goes to the back, and you end up with an array that's the same length as you started before. So if we do a rotate 5 times for that short array, we'll end up back at the original array. All right, so let's call rotate and then print it out. Let me put in a little print statement here to let us know that we did a rotate. Let's take a look. So we started out with 41903, and then more, and then ends with -5 and 10. And then here, we can see that the first element is a 1. So this one came down here. This one came down here. So everyone shifted down by 1. And the 4 that was at the beginning is now at the end. I see a question here. Why did we use length minus 1 instead of just length? Which is what you might think, since our loop went from 0 to length minus 1, and we want to do, 1 more than that. Why don't we just use length here? So what would we do? What would happen if we used length inside the array index? Well, what would happen here is, well, in this case, the length of the array is 5. So what we're saying is we want to access element number 5. But there is no element number 5. That's off the end of the array. So the largest index of the array of length 5 is going to be 4. And that's why we want length minus 1 here, to make sure we're getting the last element of the array, not going beyond the element of the array. Well, beyond the last element of the array. I'm curious to see what would happen if we go ahead and do that. So the 4 that was there disappeared. The 4 that was in element number 0 disappeared. And we got 2 10s here. Why'd that happen? What happened to the 4? Well, the 4 essentially got put in the slot over here, behind this last 10.
I can't see your screen.
Oh, I'm sorry. No wonder no one's saying anything here. Thank you. So I swapped in length for length minus 1, and I ran the program, and we got this output. So the 2 10s ended up being over here, and there's no 4. So the reason for that is kind of like this picture here. After running that loop, we ended up with 2 repeated elements at the end. And then we took that temporary variable, which was stored in temp, and we stuck it here after the end of the array. But our print array knows what the true length of the array is supposed to be. There's only supposed to be 10 elements in there. And so it only printed out 10, even though we actually stuck the first element, or that temporary element, behind the end of the array. So it's there in memory, but our print array didn't print it out. I kind of want to, in case this is not clear to you, what's going on, let's go ahead and put this into that visualizer. Oh, I'm kind of excited today because last week they were saying the server is going to be upgraded on the 15th. Guess what today is? So maybe it'll be faster today. I don't need this whole main, but I'm gonna go ahead and copy this whole thing in. I'm gonna paste it in, and I'm just gonna take out the stuff we don't need. So we don't need input array. Let's get rid of that, and we don't need double because we're not doing that. And we're not doing max int, and we're not doing sum and average. Let's go ahead and have it. Let's see, I'm not even going to have it printed out first. I'm just going to call float, or call rotate. Okay, so we have print array. I'm not even going to have it print out the array because we'll be able to see what the array is just on the screen. Well, something is different. I can already tell something's different. What I can tell is this like frame used to be in the middle of the screen. It was like centered, and now it's all the way to the left. So that's different. Anyway, let's go with this here. Okay, so we'll end up filling this array in, and now we're going to call rotate. So our array variable points to the nums array inside of main. The length is 10. Then we're going to grab the 0th element, which you can barely see back here is a 4. And we're going to put that into temp. And now we're going to start our loop. So you're going to see the values of this array get overwritten as it moves down the array. There's our repeated 10. Now the loop is done, and it should take this temporary value and put it back at the end of the array. Oh, I have a bug. I left the bug in the program accidentally. Now I have to go back and edit the program and put that back in. Okay, I can just zip this forward. We can skip all this array stuff. Now we can go one step at a time. So now we should see this 4 end up in the last element. There it goes. And there's our array. Okay. So what I wanted to show you there was if you can't figure out how the loop is supposed to run, or you give it a shot and it doesn't seem to be working quite right, take a step back and literally write out the statements it would take in order to do the job. Don't worry about the loops. Then once you got all those statements down, you can now look at those statements and figure out which ones are only running once. Those will go outside the loop. Which ones are running multiple times and are very similar. Those go inside the loop. And then figure out, are there patterns within the numbers that are changing so that I could potentially calculate one number from the other number, and that'll reduce the number of variables you need, potentially make your loops a lot simpler. My little story about that was a few years ago, I was taking one of those MOOC courses, M-O-O-C, which stands for Massively Online Open Courses. And this one was in doing image manipulation using, well, it wasn't specifically about image manipulation, but the assignment was to do image manipulation, but we were doing programming for your GPU, your graphics processing unit in your computer. For a card like an AMD card or an NVIDIA card, you could have hundreds, if not thousands, of little tiny processors that can each do one little job. For something like rendering a 3D image or the screen on a game, each one of those processors can basically be assigned to figure out what color each pixel on the screen should be. So their job might be just to maybe take one little portion of the screen right here, and just figure out what should be the image to display in that little portion. And you just farm out that job to your hundreds or thousands of processors, and all of them can figure that out in parallel. And so we were writing programs to do just basic image manipulation. In this case, the job was to blur the image. Just make it a little fuzzy. And the way you do that is you take every pixel and you average its color with its 8 neighbors. So every pixel gets averaged with its 8 neighbors. Well, that seems easy enough, right? But how do you write that loop, right? So you have a loop that has to scan across the image, each row, and then there can be hundreds of columns within that, and then every single pixel has to be averaged with its 8 neighbors. So now you need loops within loops, because now you have a little tiny loop that has to run horizontally and vertically around that pixel. And then you have literally what are called edge cases, like right over here. You've got a pixel that has no neighbors over to this side. And over here, you have pixels that have no neighbors over to this side. And up here in the corner, you have pixels that have no neighbors on the top and on the sides. So there's lots of literally what are called edge cases. And so I spent like hours trying to figure out what is the loops I need to make this happen. And I just couldn't get it. Right? I'd run the program, it would look like it was blurred, but then when we would compare it against what it was supposed to be, we would see that some of the pixels were off by a little bit. And so that was considered an incorrect solution. And so finally I just sat down and I did basically this analysis, but with a 2-dimensional image. I just literally wrote out the statements needed to make these loops run. And then I looked at them and went, oh, I see how the calculations are done now. I can see how I can calculate the XY coordinates of this pixel from the center pixel. And I can see how to calculate when I'm at the edge and what loops I should run over there. And I can see when I'm at this edge, what loops I should run over there. And once I did that, the program just actually wrote itself. But it took struggling with those loops to begin with, and realizing they weren't quite working, for me to just stop and say, whoa, I need to do a thorough analysis of what needs to be done, literally writing out the statements, and then I can see the patterns, and then I can write the loops from there. And this just happened a few years ago. I mean, it's not like this happened way back when I was in college and I was just a young guy, right? I was just doing this. I mean, it was for fun, but I'm an experienced programmer, and I could not write those loops to begin with. I could not write them the first time, or the second time, or the 10th time. I couldn't get those loops to work correctly. But I do know when that happens, it means I just need to do a little more work up front to figure out what the code should actually be. Okay, so the next program is going to be reverse. I'm going to take the array, I'm going to flip it around. So again, let's pretend that the numbers are 5, 3, 1, 2, 9. This is element 0, 1, 2, 3, and 4. And let's add one more on there. Let's put on 4 here, and that's in slot number 5. When I'm all done, I want the array to be 4, 9, 2, 1, 3, 5. So I want the first element to go in the last slot, second element to go here, this one to go here, this one here, element number 4 over into 1, and element number 5 into 0. Any ideas how to do this? Well, let's just go ahead and start writing down the statements. So if I was to move element number 0 into 5, and another way to picture it is, now here I'm showing it as 2 separate arrays, but I don't want to do that as 2 separate arrays. I want to do this in place if I can, without creating a second array. So basically, I want to move element number 0 into 5, and I want to move 5 into 0. Basically, I want to swap those two. And then I want to swap 1 and 4, and I want to swap 2 and 3. Now, if we were doing this in Java, you might just create a new array, right, and just throw away the old one and return it. But if this is C, we're not going to create a new array. We're going to do this in place if we can. I mean, another possibility is create a new array, do all this work, and then copy all the values back into the original one. But I like to avoid that if we can. This is a great little exercise to see if we can do it without creating a new array. Okay, so I don't so as much want to move 0 into 5 and then 5 into 0, because that'll end up taking the 5 and putting it here. And then we'll take that 5 and move it over here. So I end up with 2 5s on either end, and I've lost the 4. So I want to swap these two, which means I need to take one of them, store it away, then I can move this one over here, and then I can move this one over here. Okay, so we're going to do a little swap. So here's my function reverse. I've just got the stub in there for now. And then down here, we're going to call reverse print out that I did that. And then print it out. Okay, so you think you know how to write this loop? We're going to start at the beginning, work our way towards the end, and every element is going to get swapped with the one on the opposite end. So let's write out those statements there. So how would I swap element 0 and 5?
So I would look at it as 5 is at position 0, and then the 4 is at
let's see if we can just write out the statements to swap these two. So we can't just simply put like array 0 gets array 5, because that's going to overwrite one of them. So we're going to have to take array element 0 and just move it aside temporarily. Okay, so we'll create this temp variable, and it's got the number 5. And now we can move the 4 into, or element number 5 into slot 0. And then we can move this temporary variable back into slot number 5. And these three statements will swap elements 0 and 5. Okay? Now let's do the same for elements 1 and 4. We'll move element number 1 off to the side. We'll put element number 4 into element number 1, and then we'll put the temporary variable into 4. And this will swap elements 1 and 4. And then we'll do it for 2 and 3. So are we done at this point? Have we reversed the entire array, or do we have to keep going?
Yeah, we've reversed the whole array.
So at this point, we've reversed the entire array. So we actually don't need to run the loop from beginning to end. We only have to run the loop from beginning to halfway through. You can see I had 6 elements in my array, but I only had to do 3 swaps. So my guess would be if I had 8 elements in the array, I only have to do 4 swaps. If I have 100 elements in the array, I only have to do 50 swaps. So,
What if you had an odd number of elements?
what if we had an odd number of elements? That's a really good question. So if I had 5, 3, 1, 2, 9, if that was my array, I'd swap these two, then I'd swap these two, and then one of two things would happen. I would either swap one with itself, depending on how I wrote the loop, or I would just ignore the one and not swap it at all. So let's see what would happen. If I run this loop and go halfway through, there's 5 elements in the array. If I divide that by 2, what will I get? What's 5 divided by 2?
In integer division, it'll be 2.
Right. If integer division would be 2, which means was 0, 1, 2. Maybe I'll stop here at element number 2 and end up swapping it with itself. Is that okay? Maybe it's a little extra work, but the result is I end up with an array that's reversed. So I think it's going to work, but we'll try it out with both cases, okay? So let's take a step back now and look at each one of these swaps and see if we can find what's similar between them, what's changing between them, and can we replace these numbers with variables. So one thing I do see is the very first statement is going 0, 1, 2. So that's clearly just counting upwards. And this number here is also going 0, 1, 2, and it's the same as these numbers here. So if I know this number, I also know this one. If I know this number, I also know this one. And if I know this number, I also know this one. So I could replace this with like I and I, my loop counter. Now, how about this? This number here is going 5, 4, 3. And this other number is also going 5, 4, 3. So these numbers here are also the same as each other. So if I know the first number, I've got the second one. Can I calculate this second number? Can I avoid having a second variable that's counting down? Chris is nodding his head. How can I calculate this?
On in that first case, the 5 is the index of the last element. So that is length minus 1.
Good. So
and then in the next case, it'll be length minus 1 minus 1. And then in the last case, it would be length minus 1 minus 2.
Oh, so this is kind of like minus 0 up here at the top, right?
Right.
So if I get what you're saying here, this length minus 1, that's staying the same. And this number here is going 0, 1, 2. And I've seen that before, right? That was that number. Is that what you're getting at?
Right.
Yeah.
Yep.
So I can use the loop counter to calculate this number here. Now, to be honest, I might have seen this as not length minus 1 minus 0, but as just length minus 1. And the other one was length minus 2, and the other one length minus 3. So I can see that if this is going 1, 2, 3, then it's just one more than whatever this number is. So maybe I'll see this instead as length minus I plus 1. Which, when you run the minus sign through, becomes minus I minus 1. Right, so maybe this is a little bit easier for some people to see. That this number here is always one more than the loop counter. Someone's asking, can you see our comments? Yeah, absolutely, I can see your comments. But I'm working through this analysis, so you guys on YouTube are a little ahead of me as far as what loop we should be writing. So let me go ahead and let's write this. So we'll go for int I equals 0. I is less than. Sorry. Thank you for reminding me. Divided by 2. I plus plus. Int temp equals array I, and then array I is equal to array length minus I plus 1. I'll write it that second way. All right, let's save it, compile, run, and then we did a reverse. And we can see that 1 went to the end, 9 went over here, good, 0 went over here. Oh, there's 2 10s because I still have that bug in my program. Let me fix that. Let's run this again. There we go, that looks better. So now I got the 10 and 4 in the end over here, and it becomes 4 and 10 over here. So this looks like a good reversal. And then let's try what Mary asked, which was, let's make this be, where is it? Where'd it go? Where'd it go? Here it is. Let's make this be a 9 element array. So let's take off the 10. And then let's go up to the top and change the size to 9. Did it work? So what I want to find out is that the 12 end up being swapped with itself, or did it just skip over the 12 and not swap it at all? And I think to find out that answer, we can put it into that visualizer and see what was actually happening. So let me go ahead and put reverse in there. And we'll replace that call to rotate with reverse. Whoa, what? Let me copy this. We'll reload this page, paste this in. That was strange. Okay, let's try this. Okay, here we are inside the loop. The length is 10. Oh, we want to shorten this to 9. Let's try that again. Okay, so it's in the process now of swapping these numbers. This is actually a -5. And then the 4 has been brought in from the temporary variable. Now the temporary variable went away because we went outside of scope, but it'll come back. Here it is again. One interesting thing here is that temp has the value 4. Doesn't have a question mark there, because the computer just recreated that variable in the same spot where it was before. So the variable is just going in and out of scope very quickly, but the memory for that variable is still there. Okay, so it replaced, swapped 1 and 7, and we just did 2 and 6, and now we're going to do 3 and 5. And then what do you think is going to happen? Is it going to go inside the loop now? Or is it going to jump out and be done? Let's find out.
It'd jump out and be done.
It jumped out and was done. So when the length of the array is odd, it does not do that middle element at all. All right, cool. So let me introduce you to a little game that you're going to be writing this time. This is called the reverse game, and it's played like this. The computer asks you for the size of a board, let's say 6. And then it randomly fills that board in with numbers from 1 to 6. And the goal is to get that board back in order from 1 to 6. But you can only do that by asking the computer to reverse some smaller part of the board. And it has to start from the left. So for example, if I was to say 3 here, it would take the first 3 numbers and it would reverse them and leave the remaining 3 numbers the same. Let's see. So the 621 here became 126. And now, as a result of that move, my 1 and 2 are in the right spots. But everything else is kind of wacky. So, how many do I have to reverse now to get the rest of the board into the right spots? What should my next move be? If I type in, let's say 5, then it's going to take the first 5 numbers and reverse them, leaving that last number in the right spot. So I want to do these reversal moves in order to get the board from 1 to 6. Anybody know? It's a nice little puzzle, huh?
So we have to like reverse them until they're like in order.
Yeah. Someone says I should do 5 again. So if I do 5 again, now I'm back to 1 and 2 being in the right spots, but these other 4 are not in the right spots.
I don't know if it's the correct way, but I think I'd look at wanting to get the 6 at the end.
Okay.
So I would first reverse the first 3 numbers to get the 6 in the beginning.
Mm-hmm.
And then I could reverse the whole thing to get the 6 at the end.
Oh, good. Now the 6 is in the right spot.
And now we could just deal with the first 5 digits to get the 5 in the right place.
Okay. Looks like the 5 will be easy. It's already in the first spot. So if we reverse 5, that should bring the 5 to the end, not the end, the second to last spot. And it looks like 4 is now in the right spot as well. 3 is. So I think if we just reverse 2 more, we did it. Let's try that again. Let's do 7 this time. So if I reverse 7 of them, then the 7 goes into the right spot, and the 6 goes into the right spot. Now the 5 is in the right spot. And I'll reverse 4. Then I'll reverse 3, and then 2. So that's the game you're going to be doing. So in order to play this game, in order to write a program that plays this game, it has to be able to do some of the kinds of things that I just showed you how to do. It needs to be able to obviously reverse some numbers. So we've almost kind of written that function already to reverse an array. But the one you have to write for this game is not going to reverse the whole array. It's just going to reverse a part of the array. So you're going to pass in not only the array, the length of the array, but also how many elements of that array do you actually want to reverse. Then what else does this game have to do? Another thing it has to be able to do is determine if the board is now finished, if you've finished putting the board in order. So in order to find out if you've won the game, it has to look at every element of the array and figure out, are they now in numeric order? So that's one thing it has to do. Another thing it has to do is jumble up the array to begin with. So if you want to create an array that contains random values. Well, it's easy to create an array that creates just a whole bunch of random values. But in this case, the random values have to be from 1 to n, and then jumbled up. What the program does not need to do is it doesn't need to sort the array. That's our job. Our job is to play this game and sort the array, basically. So we're basically playing this game by just reversing a part of the array. Can we essentially sort it? So maybe let's take a look at how could we just create an array of just a bunch of random values. So not from 1 to n, just a bunch of random values. Let's call this function fill array random. It's just going to fill it with a bunch of random values. So this is going to go from the beginning to the end of the array. But then each element of the array is going to be filled with a random value. And let's make it a random value between like up to 100 or so. So how do we do that? So built into the C library is a function called random, but it returns a number from 0 up to some really large number. We don't want a really large number. We want just from 0 up to like 99. So a quick way to do that is basically to do modulo 100. That'll end up dividing it by 100, but giving us the remainder. And the remainder is going to be between 0 and 99. So this is the typical way that random is called if you want a range of numbers that is smaller than the range that it actually gives you. So the random function in C gives you a number between 0 and some enormously big number, and we want to scale it down. So we're going to divide by the size of the scale that we want, but use modulo, which gives us the remainder. And then we'll go ahead and print it out and do the rest of this stuff over here. So let's go ahead and try this. Oh, okay. So one problem here is that random is unknown to the program to begin with, and that's because it's in another header file. So we're going to zip all the way to the top, and we're going to put in include standard library.h, which is where the random function happens to be declared. There we go. Oh, that's not what I want to do. I don't want to do the reverse game. I want to do my program. Here we go. So here are the numbers it came up with. 83, 86, 77, 15, 93, and so forth. And it found the sum. It found the largest number. It found the average. And then it rotated everything, and then it reversed them. Let's run it again. Wait. We're getting exactly the same numbers. That's not very random. Quick little introduction to random number generators. So random number generators are a function that internally is just doing a mathematical computation on some numbers, and it's producing another number. So it's actually not a random number at all. It's a computationally predictable number if you know what the internal numbers are. So there is an initial number called the seed that is put into the random number generator. Then it does its work on the seed, and out pops a random number. And then whatever number that is then used as the seed for the next iteration. So you seed or start the random number generator with an initial value, and then from there it starts computing random numbers, and whatever random number it computes is then used as the seed for the next iteration. So you only have to seed it once. So let's go ahead in our main and seed it. srandom is the name of the function, and then you just put in a random number there. So let's put in like 57. And we'll compile our program again and run it. And we can see we get a different set of numbers this time. But since we are seeding it with the same seed every time, we get the same sequence of numbers. We have to go and change this seed, and then it will produce a new set of random numbers every time we change that seed. So how do we get it to change the seed every time? Well, one way to do it is just ensure that it is fed a different number every time the program is run. There's two ways to do this. One typical way is just to get the value of the current time. On a Linux or a Unix system, the time is stored as an ever-increasing integer that goes up and up and up and up. Every second it ticks forward one number. So if we just get the current time, we can use that as the seed for our random number generator. I'm going to go ahead and do that. I'm going to put in time, and then you have to pass in null as a parameter to time. Because what happens if you pass in an actual value there is it tries to set the clock of the system. But we don't have permission to do that, so we'll just get a program crash. We pass in a null, then it means I don't want to set the time, I just want to get the time. And then in order to use time, I have to include time.h. Okay, so now every time I run the program, as long as I don't run it twice within the same second, I will get a different set of values. The question was, what's the difference between the random function and the rand function? So they work basically the same way. They work the same, seed it, and then each iteration gets the value of the last random number to produce the next random number. It's just the two functions use slightly different calculations internally. The idea, I think, is that the random function returns a, I want to say like a 30-bit number. And the random function returns like a 30-bit number, and the rand function, I think, returns maybe a full 32 bits, or it maybe even returns like a bigger number, like a 64-bit number. So I think the rand function may be a little more random at the expense of a slightly more complicated calculation. And I think most documentation would say use rand instead of random because it's a little bit better. But for our purposes of playing a silly little game, random is just fine. I think it also has something to do with the because there's a fewer number of bits being used in the random function, it's a little easier to guess like what the next random number is going to be, because you've only got 2 to the 30th combinations to try out, which these days computers can whip through in a matter of seconds. So for example, if you were using a random number as the key to an encryption routine, and you were randomly picking the key, If you use the random function, you got like a 1 in 2 to the 30th chance of being able to guess what that key is. And so a computer program could just simply try all combinations, try decrypting your message, and get it within just a few seconds or minutes. But if you use something like RAND, maybe if there's a full 32 bits, now it's going to take like, what, 4 times longer to run that calculation? And if you have even more bits in your random number, it takes even longer to guess what it is. And so I think maybe for cryptographic purposes, using something like RAND is preferable to random. I'm speculating at this point, but I've vaguely in the back of my mind, I've got RAND is better than random for a variety of reasons. I think the true answer there is if you really want to produce random numbers, you don't use anything like the time, which is obviously very predictable, and you don't use anything like the random function, which is too easy to guess. What you want to do is use a better source of randomness. And these days, modern computers have a source of randomness called the entropy pool. You can think of entropy pool as basically a bunch of like ones and zeros that are all just floating around in there. Think of it as being like a little bucket. And then every once in a while, you want a random number, so you pull out a little cup, and you dip it into that bucket, and you pull out some random ones and zeros, and that's your random number. Okay? But the problem is that this bucket has a limited source, is a limited size. So if you dip too many cupfuls of random numbers out of this pool, eventually you'll deplete that pool, and you'll run out of random numbers. And when that happens, you start producing non-random numbers because it's no longer all mixed together. So where do these random numbers come from? So on a computer system these days, the source of those random bits come from external events that are not under the computer's control. Things like the intervals between key presses, or intervals between mouse clicks, or where the mouse is rolling around on the screen, or incoming network events. Let's see, what else could it be? Maybe on some computers, there might actually be a specific microchip on there whose sole purpose is to listen to radio waves that are coming in, over through the air. And that's essentially a source of randomness if you're listening to a channel, a frequency that doesn't have anything like music or spoken voice on it. It's just background radiation noise. So that could be a source of randomness. And there's a very famous random number generator called the lava lamp random number generator, which has hundreds of lava lamps on a wall and a camera aimed at it. And as the globs float up and down, that becomes the source of randomness. It's very slow, though. You can't produce a lot of random numbers from that. But those ones and zeros from those sources drip into this entropy pool, slowly filling it back up. And then periodically, you can dip your cupful and get a cupful of random numbers out of it. So if you dip too fast, you'll deplete that pool. So the idea is just pull out random numbers when you need it. And so that could be the source of your seed. You could pull out, let's say, 32 bits or 64 bits of random numbers from that pool and just seed your random number generator once. And then from that point forward, just use the internal calculations, which are very fast. So you would not use that entropy pool as the source of random numbers. You would deplete it too fast. You could just use it as a source to get your first seed, and then from there use your standard random number generator. On a Linux system, that random number generator is called /dev/random. And so I could I can do head-c 10, which will pull off 10 characters out of dev random. But I get just garbage values that I can't see over here. But if I could pipe it into hexdump, od-x, there we go. Then I've got, these are the byte numbers over here, so ignore these numbers here. These are the random numbers. So I got 9f, fd, 27, 9c, bf, f2, 2e, 4a, A621. So those are 10 random bytes that I pulled off of this random file. So I could potentially, in my program, I could open that file for reading. I could pull off a few bytes and then stick that into my random number generator as the seed. And then from that point forward, just use the random function. But that's too complicated for right now. We'll just use the time. It's good enough. Okay, so on Thursday, we'll come back and I will formally introduce the reverse game, although you can read it as an assignment now, and you can kind of start to see what functions you need to start writing. You need to write a function to reverse a portion of array. You've got to write a function that will randomize an array, but in this case, it's not going to fill it with random numbers. It's going to fill it with the numbers 1 through n, and then shuffle them. Kind of like getting a deck of cards. You get a deck of cards from the store, it comes all sorted. You need to shuffle it first before you can start playing with them. And so our program is going to generate a sorted array and then shuffle it up. That's actually easier to do than generating a shuffled array to begin with. It's easier to generate it sorted and then shuffle it. So we're going to fill an array with sorted numbers and then shuffle it up, and then query the user to enter the number to reverse. It's going to reverse that portion of the array, and also the last thing it needs to do is figure out, has the user now won the game by seeing if the numbers are now in numeric order. So I think there's 4 or 5 functions to write for this game, and they're all involving array manipulation. So that's what we'll do on Thursday. I'll formally introduce the assignment to you, and then we'll also hopefully get a chance to do some more fun stuff with arrays. I'm thinking about doing image manipulation. So we could take a graphical image and we do like flip it, we could mirror it, we could make it lighter, we can make it darker, convert it to grayscale, all sorts of stuff we could do to the image by just treating it as a 2-dimensional array of pixels. So that'll be on Thursday. Any questions? Oh, somebody says, didn't get random mod 100. Okay, so here's what's going on there. Whoops. Let me try that again. It's not giving me the right pen. Here we go. Random mod 100. So let's say this number here, let me write a quick little program. That'll probably be easier to do. Let's go ahead and seed the random number generator with the current time. And then we will get a random number, let's call it R. Let's just print it out. So that's my whole program there. So every time I run the program, I get a random number, and the number is between 0 and some big number. But I don't want that. I want a smaller range of numbers. So a quick way to do that is just to divide that number, but get the remainder. If I want a number between, let's say, 0 to 9, I should divide by 10, but give me the remainder. So if I divide this number by 10, I'll get 619,13733.7. But I don't want this part of it. I want just this part of it. So this is kind of a standard way of taking a large number and making it smaller is doing the modulo, which gives me the remainder after doing division. So let's go ahead and try that. Let's do mod 10. And now, why do I get 8 every time? Oh, there we go. I just coincidentally got 8 several times. Now you can see it's switching around. So every time I run the program, I get a new single-digit number. If I want the numbers between 0 and 49, then I would do mod 50. If I want a random number between 0 and 7,327, I would do 7,328. So always one more than the number, the maximum number that you want. Every time I run the program. Now sometimes I get a repeat because I'm running this twice within the same second. Or it may be coincidentally repeating. So I just need to slow down how often I run this. Now, last thing is, let's say I want a number not between 0 and 9, but between 1 and 10. So I'm still going to do mod 10, but now I'm going to add 1 to my answer. And now we should see occasionally a 10 should pop up. There it is. And we should also likewise never see a 0. Okay. Now, another question came up. Isn't it kind of dangerous to use a random number generator in any kind of loop? So, because the seed for it is based on the seconds of the computer clock. Not really. The idea is that you're going to seed your random number generator just once. Do it at the beginning of your program, and then within your loop, you're no longer using the current time. You're only using that current time once, just to generate that seed. And then from that point forward, you're using the internal calculation of the random number generator. So the random number generator does not use the current time over and over again. It only uses the current time once at the beginning of the program. Okay, so let me flip back here. So a statement like this does not tell the computer, seed the random number generator with the time every time you want to generate a random number. It seeds the random number generator once with the current time, stores that away in a variable, and then uses that as the seed for the first iteration. Okay, does that answer your question? Can I use milliseconds? Yes, so that might be a better way to do it. Instead of using the number of seconds, you could use the number of milliseconds. However, getting the number of milliseconds is a little more complicated. So I don't want to get into that just yet. I mean, it's not that much more complicated, but it's not as simple as just simply doing one system call, one function call, and getting the time. What will happen is you'll get the time, but it'll be broken down into some pieces, and then you have to reassemble those pieces. This course, we may do some simple games, like you're seeing a simple game here, but it's not a course for doing video games. So unfortunately, this will not be a place to learn how to program Pac-Man. All right, so that's all I've got for today. Again, come back Thursday and we'll do some image manipulation stuff. Any questions? No? All right. So take care, y'all.
Thank you.
All right.
Bye.
Bye-bye. All right, let me catch up on these YouTube comments. So 50, my bad. There's nothing to apologize for there. Maybe it's just like misunderstanding a little bit what's going on behind the scenes. So again, by setting that srandom statement here, you're not telling it every time you generate a random number, use the current time. You are pulling out the time once, whatever number that is, that gets plugged in as the value for srandom. And that, like I said, just gets stored away in a variable. Actually, it gets stored away in a variable as the seed. And then every time you now call the random function, that seed gets overwritten with the next number that comes out of the calculation. Yes, I'm teaching 2 classes. Tuesdays and Thursdays are the C programming class, and Mondays and Wednesdays are a course called Discrete Structures, where we're going over the kind of mathematical and theoretical foundation for computer science. Currently, we are doing Boolean algebra and logic statements and learning how to simplify them using a visual technique called Karnaugh maps. And then once we get done with that, we're going to start moving into modular arithmetic and cryptography. So these are the same 2 courses every semester. So this will be running through, where are we now? We're in February, so this will be running through May. And then we'll take the summer off, and then we'll come back in late August and start the cycle all over again. I started streaming to YouTube in, I think it was October of last year, which was about halfway through the semester. Which means once we get to the halfway point here, then we'll have done a complete cycle. So if you go back through my channel, you can see all the live sessions I did starting in October. And so you're basically watching the last half of the courses. We're now doing the first half of the courses. So once we get to about March or so, we'll have done a complete cycle, although we started halfway through. And so now you'll have basically a complete course. But I'll continue to keep streaming these so that one complete course will run from January to May. So in this particular course, once we're done with arrays, then we'll be getting on to pointers. Then pointers open up a whole bunch of stuff we can do. We'll start doing, so we'll learn about hashing and password cracking and complex data structures, and then we'll get into network programming and a little bit of, I'm trying to think what else do I have in store for us. I'm drawing a blank right now. I'm not in the mode of thinking about the last half of the course. And then in the other course, once we get done with cryptography, we will then move into things like sets, graph theory, regular expressions, programming languages, compilers, and using that all as kind of a vehicle for learning about graph algorithms, set theory, finite state machines, all stuff that I think is important for a computer science student to learn as to provide a nice solid foundation on which you can build your other courses. May differ a little bit from other discrete math or discrete structures courses out there, but this is what I think works, and it works well for students who are transferring out of my institution and going on to other institutions where they've now had a little bit of an introduction to a whole bunch of stuff, and they can use that to leverage their further learning. Oh, he decided to be a mechanical engineer? I mean, I think that's pretty cool too. Maybe you can be one of those crossover people that knows a little bit about both. There is actually kind of a field in the middle. There's computer science, which is typically mostly software, And there's mechanical engineering, which I like to think of as being like hardware. But kind of in the middle, there's mechatronics, which is how to apply computer programming to things like robotics and mechanical machines that are controlled by computer. Think about gas pumps, and around here we have like the machines to run ski lifts, right? Those also are, you know, mechanical machines, but controlled by computer. So maybe there's something that lies in the middle of your interests. If you like computer science, but you're also mechanical engineering, find something in the middle. Having people that know a little bit about both fields, like, highly desirable. Okay. We'll get plenty of time to talk other times. But I need to go and get some stuff done. I hope you all have a good day. It was great, having fun. And we'll come back on Thursday and do more array stuff, or you can tune in on Wednesday and learn a bit more about Karnaugh maps and how they can be used to simplify Boolean expressions, and how we can build practical things like LED displays out of Boolean expressions. So tune in for that if you'd like. So at this point, I'll say goodbye. Take care. Have a good day. Talk to you later.